On January 19, 2006, New Horizons launched as the fastest object humanity ever built, screaming out of the atmosphere at 36,000 miles per hour. It has now traveled over 5 billion miles beyond Pluto, into a region so dark and silent that objects have remained chemically frozen since the birth of the solar system. In 2019, it photographed something that should not exist, Arrokoth, a snowman-shaped contact binary asteroid, pristine and untouched for 4.5 billion years. But here is the paradox: despite being billions of miles from Earth, transmitting with a signal weaker than a refrigerator light bulb, we received images sharp enough to see boulders the size of cars on its surface. How is it possible to transmit ultra-high-resolution data across interstellar distances with only 12 watts of power? And looking at the dying nuclear battery, how much longer will we be able to decode the alien origins hidden in this frozen time capsule? To understand the Arrokoth ghost, you have to understand a counterintuitive detail about the mission's evolution. New Horizons was designed for Pluto, but the real scientific treasure hunt began after the flyby ended. The spacecraft still had fuel, functioning instruments, and years of battery life remaining. Mission planners scoured the Kuiper Belt for a second target. The original mission was a one-shot reconnaissance of Pluto. But a special circumstance enabled the extended mission, the Hubble Space Telescope's Deep Search campaign. Astronomers scanned the predicted flight path and discovered a faint dot, Arrokoth, originally designated 2014 MU-69. It was perfectly positioned, reachable without major course corrections. This extended hunt delivered key achievements. First, the contact binary, Arrokoth is two separate lobes gently fused together, proving planetesimals formed through slow, gentle collisions, not violent impacts. Second, primordial chemistry, the reddish surface contains organic compounds unchanged since the solar system's birth, a chemical fingerprint of alien origins. Third, the flatness, Arrokoth is pancake flat, meaning it formed in a perfectly stable disk, challenging chaotic formation models. There is a radical divergence between the two targets New Horizons visited, and what each revealed reshapes planetary science in opposite ways. Pluto was the dwarf planet killer, a world that defied expectations by being geologically alive, with churning nitrogen seas and ice volcanoes. Arrokoth is the opposite, the time capsule. It is geologically dead, chemically frozen, unchanged for billions of years. Here is the counterintuitive comparison: Pluto is 1,400 miles wide. Arrokoth is only 22 miles long. Pluto has an atmosphere. Arrokoth has none. Yet Arrokoth is scientifically more important for understanding origins because it hasn't been altered. It may not seem dramatic, but imagine this human-scale scenario: Pluto is a city that has been demolished and rebuilt 1,000 times. Arrokoth is the original blueprint, buried in a vault, perfectly preserved. One tells you what happens over time, the other tells you how it all began. To understand where Arrokoth lives, we must define two commonly confused zones, the classical Kuiper Belt and the scattered disk. Think of the classical Kuiper Belt as a graveyard. Objects here orbit in neat, circular paths, undisturbed since formation. This is where Arrokoth resides. The scattered disk is different. It's a war zone, where gravitational chaos from Neptune flings objects into wild, elongated orbits. We can see the exact moment of transition in the data. New Horizons crossed into the classical belt in late 2018, entering a region of maximum pristine density. The flyby of Arrokoth occurred on January 1, 2019, 4 billion miles from Earth, 1 billion miles beyond Pluto. Place this in the larger timeline: 9.5 years to reach Pluto, 3.5 additional years to reach Arrokoth. The probe is now coasting even deeper, hunting for dust density signatures that reveal how planets condense from chaos. So here is the core mystery, the miracle mechanism. How do you photograph a 22-mile-wide snowman in the outer dark and transmit those images back across 4 billion miles with a transmitter drawing only 12 watts of power? That is less than the nightlight in a child's bedroom. The challenge is the signal delay. Here is the perspective ladder. Light takes 1.3 seconds to reach the moon. Light takes 8 minutes to reach the sun. The signal from Arrokoth took 6 hours to reach Earth. The signal obeys the inverse square law, it spreads out exponentially as it travels. By the time it arrives, it is a whisper lost in the cosmic static. To catch it, we rely on the 70-meter dishes of NASA's Deep Space Network. These massive receivers in California, Spain, and Australia operate in continuous relay. As Earth rotates, one dish loses the signal and hands it off to the next. If the global network goes offline, New Horizons screams into the void alone. The problem isn't the receiver on Earth, it's the dying ember aboard the spacecraft. Solar panels are useless this far out. The sun is just another star. New Horizons runs on an RTG, a slug of decaying plutonium-238 that converts radioactive heat into electricity. It launched with 245 watts of power. Today, it generates roughly 190 watts. Every year, we lose about 3.5 watts. We are already in power triage. We cannot run the transmitter, the scientific instruments, and the heaters simultaneously. We must cycle them on and off. We are approaching the moment of the final photograph, the day when the camera will be shut down permanently just to keep the carrier signal alive long enough to finish transmitting data already stored in memory. Reaching Arrokoth was not a smooth glide. The mission faced critical failures that nearly ended the extended mission. During the approach to Arrokoth, the star tracker, used for precise navigation, locked onto a cosmic ray and misidentified it as a star. The spacecraft lost orientation. The automated fault protection system recognized the error and switched to gyroscopic mode, preventing a catastrophic tumble. Then there is the thermal crisis. As the RTG cools, waste heat that once kept the fuel lines warm is vanishing. If the hydrazine fuel freezes, the thrusters fail. If the thrusters fail, we cannot point the antenna. Engineers are currently rewriting the onboard code to use the heat from the electronics themselves as an emergency thermal blanket, buying us a few extra years. The math is merciless. Current projections give us until the mid to late 2040s, at most, 15 to 20 years remaining. The power curve is irreversible. The connection is finite. The silence is inevitable. Launched in 2006 with processors slower than a first-generation iPhone, New Horizons photographed the alien origins of the solar system. Even when the battery dies and the transmitter falls silent, the machine will continue to drift through the Kuiper Belt and into the Oort cloud, a frozen monument carrying the ghost of Arrokoth into eternity.